So in the topic permutations, let us discuss first what is factorial of a number, right? Factorial of a number n is denoted by factorial of a number n is denoted by so these are the two ways of representation. Both here read as n factorial and defined as n factorial equal to product of first n natural numbers, that is n into n minus 1, n minus 2, n minus 3, and so on, 3 into 2 into 1. Let us take an example. 5 factorial equal to 5 into 4 into
120.
3 into 2 into 1, that is 120. 4 factorial 4 into 3 into 2 into 1,
24.
24. This 5 factorial I can also write as 5
into 4
in
factorial.
bracket 4
factorial.
into 3 into 2 into 1, that is 5 into 4 factorial. So n factorial equal to n into n minus 1, n minus 2, n minus 3, and so on, 3 into 2 into 1. So 5 factorial you can rewrite as 5 into 4 factorial. So in the same manner, so n factorial can be written as n into n minus 1 factorial. So from this, I can write as n minus 1 factorial equal to n factorial upon n. Now let us take few numbers. Let us take n equal to 4. Now when I take n equal to 4, left side will be 3 factorial equal to 4 factorial upon 4, which is 6. If I take n equal to 3, left side 2 factorial equal to 3 factorial upon 3, that is 2. When I take n equal to 2, 1 factorial equal to 2 factorial upon 2, which is 1. When I take n equal to 1, left side 0 factorial equal to 1 factorial upon 1, which is 1. This is one way of explanation of showing 0 factorial equal to 1. Factorial is not defined for negative numbers and fractions. Fundamental principle of counting. Fundamental principle of counting. In this first one, addition law. Fundamental principle of counting in this first one, addition law. If an operation can be performed in m different ways, and another operation independent of first operation, can be performed in n different ways, then either of the operations can be performed in m plus n ways. See once again, addition law. If an operation can be performed in m different ways and another operation independent of first operation can be performed in n different ways, then either of the operation can be performed in m plus n ways.
What does independent?
Example, in a library, there are 5 math books and 4 physics books are available. In a library, there are 5 math books and 4 physics books are available. The number of ways a student can take either math or physics book is 5 plus 4, that is 9 ways. This is the addition law. So under fundamental principle of counting, second one is multiplication law. If an operation can be performed in m different ways, follows to it another operation can be performed in n different ways, then the two operations in succession can be performed in m into n ways. This can have an extension also. So in a library, if you have 6 physics and 5 chemistry books are available to a student, the number of ways of choosing a physics and a chemistry book is 6 into 5, which is 30 ways. If the objects arranged in a row, Sir,
is this a question?
No. If the objects arranged in a row, then it is said to be a linear arrangement. If the objects arranged in a row, then it is said to be a linear arrangement.
Sir, Nihar is in the waiting room.
if the objects arranged in a circular manner, if the objects arranged in a circular manner, then it is said to be a circular arrangement. So in general, when it is not mentioned, always we consider as what? Linear arrangement only. If it is specifically mentioned, then only we'll consider. Otherwise, always objects arrangement will be considered as a linear arrangement. Next, permutation. Permutation. Each of the different arrangements, each of the different arrangements that can be made each of the different arrangements that can be made by taking some or all of a number of objects is called a permutation. Each of the different arrangements that can be made by taking some or all of a number of objects is called a permutation. Let us take an example so that it will be more clear. Let us consider here having 4 objects A, B, C, D. Now, number 1, list all possible arrangements. List all possible arrangements taking 2 at a time. List all possible arrangements taking 2 at a time. One is AB, AC, AD, BC, BD, CD. Now, not only this, even you can have BA, CA, DA, CB, DB, DC. That is total number of arrangements of 4 objects taken 2 at a time. 12. Now, in the same manner, let us list three at a time. 3 at a time. That is, list all possible arrangements of 4 objects taking 3 at a time. ABC, ABD, ACD, BCD, ACB, B AC B CA C AB C BA. Exactly in the same manner we can have for the second one also. A DB B AD B DA D AB D BA. Next, ACD can rewrite as A DC C AD C DA D AC D CA. Now, again in the same manner for BCD also we can write B DC C BD C DB D BC DC. Now, so number of arrangements of 4 objects
24.
taking 3 at a time is
24.
24. Now, instead of listing 2 objects at a time or 3 objects at a time, the same problem can be discussed in a different way as first bit. Now, because I want to have only 2 objects at a time, I am considering 2 blanks. Now, the first blank can be filled with any of the 4 objects. That means first blank can be filled any of the 4 objects, means there are 4 possibilities are there. After filling the first blank, I have to fill the second blank. When I am filling the second blank, the number of objects available will be only 3. That means there are 3 ways. Now it is like first operation means first blank can be filled in 4 ways and second blank can be filled in 3 ways. But here this is a simultaneous operation. That is after filling the first one, I have to fill the second one. That means this comes under product law. That means 4 into 3. That is what 12 ways in the first bit. Exactly in the same manner, if I consider 3 blanks, that is for the second bit, 3 at a time. So the first blank can be filled in 4 ways and the second blank can be filled in
3
3
ways.
ways. The 2 blanks together can be filled in 4 into 3 ways. Now again, after filling the first blank, second blank, the third blank can be filled with
2
2
ways.
ways. Why? Because only 2 objects will be left out. So the number of possible arrangements will be 4 into 3 into 2, which is 24. So instead of listing and counting, so it is like filling the blanks using the given objects. Number of permutations. Remember, permutation means it is an arrangement only. So number of permutations of n distinct objects, number of permutations of n distinct objects taken are at a time. Number of permutations of n distinct objects taken are at a time is denoted by n p r. This is one notation. Another notation is you can write like this n p r, and one more notation is even you can write like this n p r, or one more notation is p in bracket n comma r. So all are same only. That is number of permutations of n different objects taken
Taken
r
at
at a
time.
time, which is same as filling r blank places, which is same as filling r blank places using n different objects. That is, so we are having r blanks and available are n different objects. Now, that means n p r equal to, the first blank can be filled with any of the available n different objects in n ways. The second blank has to be filled with the remaining objects. So remaining objects are n minus 1. So the second blank can be filled with n minus 1. Now the first two blanks in succession can be filled in n into n minus 1 ways. In the same manner, third blank in n minus 2 ways, and so on. The rth blank, so the first blank is n, second is n minus 1, third is n minus 2, and so on. So the rth blank will be
N minus r
r plus 1.
plus 1.
That is n p r equal to n into n minus 1, n minus 2, and so on, n minus r plus 1. Now this we can rewrite in another form as using factorial notation. Now if you observe this,
Yes,
this go
sir.
on decreasing. That is n minus 1, n minus 2, and so on. So let us multiply some number and then divide such that it can be converted as a n in terms of factorial. So n into n minus 1, n minus 2, and so on, n minus r plus 1. If I reduce one more, then it becomes n minus r, then n minus r minus 1, and so on, 3 into 2 into 1. That is, we are multiplied with n minus r minus 1, 3 to 1, and divide n minus r minus 1, and so on, 3 into 2 into 1. Now if you observe the numerator, it is product of first n natural numbers. That is n p r equal to n factorial upon n minus r factorial, where 0 less than or equal to r less than or equal to n. So this is the formula for NPR. Number of 3-digit numbers, number of 3-digit numbers with distinct digits. Number of 3-digit numbers with distinct digits. So how many will be there? So it is like again filling up of what? Because we need 3-digit numbers. So that means take the 3 blanks. Now you have to fill with what digits? What are the available digits? 0, 1, 2, 3, 4, up to what? 9. So these are the available digits. So using this available digits, you have to fill the 3 blanks. Condition is what? Digits must be what? Distinct, and it's a 3-digit number. When it is a 3-digit number means the first blank cannot be start with a 0. No. So first blank cannot start with a 0. So the possibilities of filling the first blank is what?
9.
1 to 9. Now in the second blank, 0 can come, but the digit which is used cannot be taken in the second blank. That means the number of ways of filling the second blank is again how many?
9.
9. Now simultaneously these two blanks can be filled in 9 into 9. Next, in the third blank 0 can come, but the digits which are used in the first and second cannot be used. That means how many possibilities will be there?
8.
8. So total number of 3-digit numbers with distinct digits will be 9 into 9 into 8.
48.
How much?
648.
648. Next, number of permutations,
Sir, is it a
number
question?
of
So is it a question?
right, number of permutations of n distinct objects, number of permutations of n distinct objects taken all at a time. Number of permutations of n distinct objects taken all at a time is what?
N factorial.
Factorial.
N factorial.
N factorial. That is how to calculate it. It is like again filling how many blanks? N blanks. And how many objects are available is n. So the first blank can be filled in n ways, second blank in n minus 1, third is n minus 2, and so on. 3, 2, 1. So the number of ways will become n into n minus 1, n minus 2, and so on, 3 into 2 into 1, which is same as what? N factorial. Now, in terms of symbolic form which you have used before, that is r equal to n. That means it will be what? N, P, N. So n, P, N equal to n factorial. Now if I apply the formula what you have written before, NPR. So if I apply for NPN, it will be n factorial upon n minus n, that is 0 factorial, equal to again n factorial I am getting. That means from this also I can show it as 0 factorial equal to n factorial upon n factorial, which is 1. This is another way of showing 0 factorial equal to 1. Number of permutations of n distinct objects, number of permutations of n distinct objects taken are at a time in which each object, number of permutations of n distinct objects taken are at a time in which each object can repeat any number of times. That is basically here repetition is allowed.
Sir, it will be
The
n to the
answer is
power
what?
N to the power r.
N to the
n
power
to the
r.
power r.
It is same as what? Again filling
N
r
into
blanks
n.
only. Filling
But with
r
n
blanks
in each
using
blank.
n distinct objects. Now the first blank can be filled with n distinct objects. Again the second blank also has possibilities n, because the object can be repeated. So the first two blanks in a cyclic or in a succession can be filled in n into n. So n into n into n into and so on. How many times n is?
R times
R. So it will be n to the power of r.
r.
That is number of permutations of n distinct objects taken r at a time in which each object can repeat any number of times is n to the power of r. Next. Number of permutations of n distinct objects taken, number of permutations of n distinct objects taken, not more than r at a time. First one, repetition is not allowed. Second, repetition is allowed. So in the first one, npr upon n minus 1 pr minus 1, we have simplified and this equal to n. Now here npr equal to n minus 1 pr plus r into n minus 1 pr minus 1. Take the right hand side and apply the definition. N minus 1 factorial upon n minus 1 minus r factorial, which is same as n minus r minus 1 factorial, plus r into n minus 1 factorial upon n minus 1 minus r plus 1. So n minus r factorial. And n minus r factorial can be written as n minus r into n minus r minus 1 factorial. So you can take common from these two as n minus 1 factorial upon n minus r minus 1 factorial. So remaining will be 1 plus r upon n minus r. Simplify and then again convert into factorial notation. So which will be same as npr. Now you think of theoretically what can be the explanation for this. So npr equal to n minus 1 pr plus r into n minus 1 pr minus 1. The theoretical explanation of splitting for this is left side corresponds to permutations of n different objects taken r at a time. That means each arrangement must have r objects. That entire number you can split into two parts such that in each arrangement one specific object does not contain will be n minus 1 pr. In each arrangement one specific object is always there. That will be r into n minus 1 p r minus 1. That is, we are fixing one specific object which is always included and which is always excluded. That is what the splitting of these two. Number of permutations of n different objects taken r at a time in which first bit two specific objects occur together. Second bit two specific objects occur always. So when two specific objects occur together means out of r blanks two specific objects occur together because you are having r blanks. Those two specific objects can be in the first and second, or second and third, or third and fourth, and so on. That means the possibilities are r minus 1 and the objects can be interchanged also. So 2 into r minus 1. Now after filling those two objects, the remaining way you have to fill it is r minus 2 from n minus 2. That's why it is 2 into r minus 1 into n minus 2 p r minus 2. That is what the first bit. Two specific objects occur together. Because occur together means what? Consecutive. Or it can be interchanged. Whereas in the second bit, two specific objects occur always. occur always means they can be anywhere. So anywhere means one way of expressing it RP2, because two objects can be anywhere out of R positions. So RP2, and they can be interchanged. That is 2 into RP2 into n minus 2p R minus 2 R. First object you can fill it in out of R blanks, R positions. The second object can be R minus 1 positions. So together will be R into R minus 1, and interchanging can be done. So 2 into R minus 1. For the remaining blanks, it will be n minus 2p R minus